Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the area of square ABCD. In the second question, we'll find out the size of this angle theta, that is in triangle DOE. To start with the first question, in the drawing we have a square ABCD. We know that line segment AP equals to 5 units, line segment BP equals to 3 units, line segment CP equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we'll do a construction. We'll extend side DC of the square by a straight line. And from point P, we will draw perpendicular on the extended DC. Again, from point P, we will draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point P in the extended DC as N. In the next step, we will do another construction from this point B. We will draw perpendicular on PN. Again, from point B, we will draw perpendicular on PN. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and PN as M. We will define side BM, this side SA, again side BM equals to A according to our definition, and we define side PM as B. Okay. In the next step, we will implement the Pythagoras theorem on the green right triangle PBM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The right straight triangle PBM the hypotenuse is PB, therefore the square of the hypotenuse will be equal to PB square and it must be equal to the sum of the square of the perpendiculars. That's to say, it must be equal to PM square plus BM square. Here by PT is abbreviation for Pythagoras theorem. I repeat again, in the right plane triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. According to what is given as the question, PB equals to 3 units. Therefore, PB square is 3 squared, that is 9. And it is equal to PM square. PM equals to B, therefore PM square is B square plus BM square. BM equals to A, therefore BM square is A square. So, in conclusion, found out that according to the question number 1, A square plus B square equals to 9. Okay. We know that all the angles inside a square are right angles. Therefore, inside square ABCD we have 4 right angles. Okay. And here DC is one side of square ABCD, therefore it is absolutely a straight line. Then we extended the straight line DC by a straight line, and the result is DN. When you extend a straight line by a straight line, the result must be a straight line, therefore DN must be a straight line. So I'll write it down. DN is a straight line. I'll repeat again. Line segment DN is a straight line. So if we focus on the upper side of the straight line DN at point C, the sum of the angles here must be equal to 180 degrees. So which angles we have at point C in the upper side of DN? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. So therefore, the missing angle must be also equal to 90 degrees. According to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be equal to 90 degrees. So actually, we found out that inside quadrilateral BMCN, inside this quadrilateral, we have 1, two free right angles. The sum of free right angles is 270 degrees, and according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in quadrilateral BMCN to 360 degrees. This angle must be equal to 90 degrees. So we will focus on the lower side of line segment AEM at point B. In the lower side of AEM at point B, we have this angle that is equal to 90 degrees, plus this angle that is also equal to 90 degrees. In total, those two angles is 90 degrees plus 90 degrees, that is 180 degrees. Okay, so we can write down that ABM, angle ABM equals to 180 degrees. Okay, angle ABM is equal to 180 degrees. And we know that any angle that is equal to 180 degrees, it is a straight line. Therefore, angle ABM that is equal to 180 degrees is a straight line. Repeat again, this angle ABM is a straight line. If angle ABM is a straight line, it means that line segment ABM is also a straight line. Line segment ABM is a straight line. And if line segment ABM is a straight line, it means that line segment AEM is also a straight line. Line segment AEM is also a straight line. And if line segment AM is a straight line, it means that APM is a right triangle. Again, APM is a right triangle. Okay? APM or shape APM is a right triangle. So we can implement the Pythagoras theorem on the right triangle APM. So in the right triangle APM, by PT, it is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, again, we will implement the Pythagoras theorem on the right triangle APM. So according to the Pythagoras theorem, AP square is equal to BM square am square. We will define the side length of the square as x, therefore all of its sides will be equal to x unit in their lengths. So here, according to the Pythagoras theorem, in the green triangle APM, AP square equals to BM square plus AM square. AP equals to 5 units according to what is given as the question, therefore AP square is 5 square, that is 25, and it is equal to BM square. BM equals to B, therefore BM square is B square plus AM square. AM, it is very easy to see that the length of AM is x plus A. So AM equals to x plus A, therefore AM square is x plus A square. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus x plus A square. Here we'll open the brackets on this side of equation number 2 and we get that according to equation number 2, 25 equals to B square plus x plus A square. X plus A square equals to x square plus A square plus 2 times x times A. So here in equation number 2 we have B square plus A square. But we have already found out that according to equation number 1, B square plus A square equals to 9, therefore we substitute B square plus A square by 9 in equation number 2. And we get that according to equation number 2, 25 equals to B square plus A square is 9 plus x square plus 2ax. Here we subtract 9 from this equation number 2, and we get that according to equation number 2, (25 minus 9 is 16), and it is equal to x square plus 2ax. Here we subtract x square from this equation number 2, and we get that according to equation number 2, 16 minus x square equals to 2ax. Here we divide this equation number 2 by 2x, and we will get that according to equation number 2, A equals to 16 minus x squared over 2x. So we found the value of A in terms of x. Okay. We have already found that in quadrilateral BMCN, this quadrilateral, we have 4 right angles. Therefore, quadrilateral BMCN that has 4 right angles, it is a rectangle. So we will relate to quadrilateral BMCN as a rectangle. I write it down. Quadrilateral BMCN is a rectangle. Because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side BM equals to side CN. BM equals to CN. But we have, according to our definition, BM equals to A. So for this equation, A equals to BM equals to Cn, we will derive that Cn is also equals to A. Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will here in rectangle ABDN, in rectangle BMCN, BC equals to MN. BC equals to MN, but according to our definition, BC equals to X. So if you like, BC equals to X, and from this equation, X equals to BC equals to MN, we will derive that MN is also equals to X. MN is equal to X. So I feel that MN equals to X. In the next step, we will implement the Pythagoras theorem on the right, in the right green triangle, triangle PCL. So in the right green triangle, triangle PCN, by PT, the relation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle, triangle PCN is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the square of the perpendiculars, that is to say, it must be equal to Pn squared. plus cn squared. Repeat again. Divide when triangle PCN according to the Pythagoras theorem, we get that PC squared equals to Pn squared plus Cn squared. PC equals to 6 units, therefore PC squared is 6 squared, that is 36. Is equal to Pn squared. Here it is very easy to see that Pn equals to b plus x. Therefore Pn squared will be equal to b plus x squared plus Cn squared. Cn equals to a, therefore Cn squared will be equal to a squared. So in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we'll open the brackets on this side of equation number 3 and we'll get that according to equation number 3, (36) equals to b plus x squared equals to b squared plus x squared plus 2 times b times x plus a squared. Here we have, inside the equation number 3, we have b squared plus a squared, and according to equation number 1, b squared plus a squared equals to 9. Therefore we substitute b squared plus a squared in this equation number 3 by 9. And we get that 36 equals to 9 plus x squared plus 2bx. We substitute b squared plus a squared by 9. Here we subtract 9 from this equation number 3, and we get that according to equation number 3, 36 minus 9 is 27. That is equal to x squared plus 2bx. Here we subtract x squared from this equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. Here we divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. So we have the values of a and b in terms of x. And according to equation number 1, we know that a squared plus b squared equals to 9. Therefore, we substitute a squared and b squared in equation number 1 by the values that we found for a and b. So we have already found out that a equals to 16 minus x squared over 2x, and if we square the expression, we get the value of a square plus b square. We just like now found out that b equals to 27 minus x squared over 2x. And if we square the expression of b, we get b squared. And according to equation number 1, it is equal to 9. Okay, so we substituted a and b by the values that we found for them, and we got this expression. So here we'll open the brackets on this side of equation number 1, and we'll get that 16 minus x squared equals to 16 squared, that is 256, plus x squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared, all divided by 2x squared, that is 4x squared. But because of the fact that the denominator of those two expressions are equal, we will add the numerator of the two expressions to each other. Because you can do it because we have the same denominator. And we will get that 27 minus x squared equals to 27 squared, that is 729, plus x squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared, and it is equal to 9. So here 256 plus 729, it is equal to 985, plus x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared, all divided by 4x squared equals to 9. Here we multiply this equation number 1 by 4x squared, and we get that according to equation number 1, two times x to the power of 4 minus 86 x squared plus 985 equals to 9 times 4x squared is 36 x squared. So here we will subtract 36 x squared for this equation number 1, and we get that according to equation number 1, 2 times x to the power of 4 minus 36x squared minus 36x squared is minus 122x squared plus 985 equals to 0. So here we define z as x squared, z equals to x squared according to our definition. So if z equals to x squared, it means that z squared will be equal to x to the power of 4. So this expression in total will be equal to 2 times z squared minus 122, and according to our definition x squared equals to z, therefore we substitute x squared by z plus 985 is equal to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So I write it down. Repeat again, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985, and the variable that we are looking for is z, so we substitute x by z, and we get that z equals to minus b. b equals to minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared is square root of minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is 7,880 over 2a. a is 2, so 2a is 2 times 2, that is 4. So we found out that z equals to 122 plus minus square root of 14,884 or 14,884 minus 7,880 is 7,004. So inside the root we left only 7,004 over 4. So z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4. So here we will have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. So here z equals to 122 plus 83.6899 is equal to 240 205.6899 over 4 and 205.6899 over 4 is equal to 51 205.6899 over 4 is equal to 51.4224. According to our definition, z equals to x squared, that is equal to 51.4224. So here we take a root out of this equation and we get that the square root of 51.4224 will be equal to x, that is equal to 7.17 units. So we actually found out that x equals to 7.17 units. Here x equals to 7.17 units, and it is actually impossible that x equals to 7.17 units. Why? Because if we focus on the right triangle, triangle APM, on this right triangle, triangle APM, the hypotenuse AP equals to 5 units. And we know that the hypotenuse is the biggest side in the right triangle, in any right triangle. That is to say, in the right triangle, triangle APM, AP is bigger than AM. AP is bigger than AM, so if AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. Okay, so we can write down that we found out that in the right triangle APM, the hypotenuse is AP and it is equal to 5 units, and it is bigger than AB, that is equal to x. Okay, repeat again. In the right triangle APM, the hypotenuse AP equals to 5 units, and it is bigger than AB, that is equal to x. So from this inequality, we will derive that x is less than 5 units. X is less than 5 units. X is less than 5 units. But we just right now found out that x equals to 7.17, that is bigger than 5 units. Okay, so we have here a contradiction. According to the drawing, x must be less than 5 units, while we found out that x is equal to 7.17 units, that is bigger than 5 units. So due to the contradiction, we cancel the solution that x equals to 7.17 units, and we'll focus on the second solution for z of the quadratic equation. So according to the second solution, z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 38.3013, and if we divide it by 4, we get that Z is equal to 38.3013 over 4 is equal to 9.5775 units. Okay, so we found out that Z equals to 9.5775 units, but according to our definition, Z equals to x squared. And we are looking for the area of square ABCD. What is the area of square ABCD? It is equal exactly to x squared. Therefore, you can write down that the area of square ABCD is equal to 9.5775 square units. And if we take a root from Z that is equal to x squared, we get the value of x. And we get that the value of x equals to 3.09 units. So here x equals to 3.09 units, and it is indeed less the hypotenuse AP that is equal to 5 units. Therefore, according to our solution, we found out that the area of square ABCD equals to 9.5775 units. So we finished with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle, triangle ABC. Angle ABC equals to 90 degrees. Inside the right triangle, we have a circle, and inside the circle, we have triangle DOE, and we are looking for this angle, angle theta. It is given us that AD equals to EC, again AD equals to EC, and DE is twice as long as AD, and it is also twice as long as AC. That is to say, AD equals to EC equals to DE over 2, and our mission is to find out the size of this angle, angle theta. Okay, so we'll define AD, DE, we'll define DE as 2A. So DE is equal to 2A according to our definition. According to what is given as the question, if we have AD that is equal to EC that is equal to DE over 2, and according to our definition DE equals to 2A, so we substitute DE by 2A, so it is 2A over 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with A. So from this long equation, we derive that AD is equal to EC that is equal to A. That is to say, AD equals to A and EC is also equals to A. Okay. In the next step, I will present to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. So here, the center of the circle is point O. From point O, we draw perpendicular OM to chord CD. And according to rule number 4, this rule, the perpendicular OM bisect chord CD. That is to say, CM equals to MD. And from the fact that it bisects chord CD, it means that each half equals to each CM equals to half of CD, that is CD over 2, and MD will be equal to the second half of CD, that is also equals to CD over 2. So we can implement rule number 4 in our drawing, because in our drawing, from the center of this circle that is actually point O, we go perpendicular on DE. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point O to DE as T. So here, according to rule number 4, dt equals to TE. dt equals to TE. So chord DE has been bisected into two halves by perpendicular OT. That is to say, TE equals to DE over 2, and DT is also equals to DE over 2. Again, here according to rule number 4, the perpendicular OT bisects chord DE into two halves, that is to say, DT equals to TE. Each half equals to DE over 2. So DT equals to DE over 2, and TE is also equals to DE over 2. But DE, according to our definition, equals to 2A, so we substitute DE by 2A over 2. We have 2 in the denominator and 2 in the denominator, so 2 will get cancelled. And here we left only with A. So from this long equation, we will derive that dt equals to TE, and it is equal to A. That is to say, dt equals to A, and TE is also equals to A. Okay. In the next step, I will present to you rule number 10, and we will implement rule number 10 in our drawing. So here we have this circle, and we have the external point P. So from the external point P, we have tangent PA that is tangent to this circle at point A. And from the same point P, we have the straight line here that intersects with the circle at point B and at point C. So if this is the data that has been given to us, then the following equation is true, that PA squared equals to PB times PC. Repeat again, PA squared equals to PB times PC. You actually can implement again PA or AP squared equals to PB times PC. So we can implement rule number 10 in our drawing. Why? Because in our drawing we have but before we do that here we define the point of tendency of tangent AB with this circle as point M. We will define the point of tendency of tangent BC with this circle as point N. We will join points O and N together by a straight line. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circles that we define as capital R. So here we have the radius ON that is drawn to the point of tendency. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to each point of tendency. This angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and M together by a straight line. Again, point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that is equal to R according to our definition. Again, we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So inside quadrilateral MOBN, we have 2 free right angles. The sum of free right angles is 270 degrees. Therefore, this fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral MOBN is 4 right angles. Therefore, quadrilateral MOBN is a rectangle. Quadrilateral MOBN is a rectangle. Why? Because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But we only found out that MO equals to R. So here, from this equation, R equals to MO equals to BN, we will derive that Bn is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get here that ON is equal to MB. ON is equal to MB, but we have only found out that ON equals to R. So we can write here ON equals to R. And from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. MB is also equals to R. Here. We only found out that NB equals to R. So here NB is also equals to R. So we actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other. So quadrilateral MOBN is a square. So in the next step we'll focus at point C. From point C we have tangent CN and we have the straight line, this straight line that intersects with the circle at point E and at point D. Therefore, according to rule number 10, here PA square equals to PB times PC. We'll implement rule number 10 at point C. According to rule number 10, we get that Cn squared equals to Ce times Cd. Repeat again. At point C, according to rule number 10, Cn squared equals to Ce times Cd. So Cn squared equals to Ce. Ce equals to A, so we substitute Ce by A times Cd. What is the value of Cd? It is very easy to see from the drawing that Cd equals to A plus A plus A, that is 3A. So we substitute Cd by 3A. So in conclusion, found out that according to rule number 10, Cn squared equals to A times 3A. So Cn squared equals to A times A is 3A squared. Here we'll take out of this equation and we get that Cn equals to the square root of 3A squared. The square root of A squared is A and the square root of 3 is square root of 3. So in conclusion, in total we found out that the square root of 3A squared equals to the square root of 3 times A. So we can write down here that we found out that Cn equals to the square root of 3 times A. Likewise, we focus on the example point A. the external point A, we have tangent AM, and we have the straight line that intersects with this circle at point D and at point E. Therefore, we can implement here rule number 10. We get that according to rule number 10, AM squared equals to AD times AE. A bit again. We implemented rule number 10, the external point A. According to rule number 10, we get that AM squared equals to AD times AE. AD equals to A, so we substitute AD by A. What is the value of AE? From the drawing it is very easy to see that A equals to A plus A plus A, that is 3A. So we substitute A by 3A. So in conclusion, we found out that AM squared equals to A times 3A is 3A squared. Here we take out of this equation and we get that AM equals to the square root of 3A squared, that is square root of 3 times A. Here we found out that AM equals to the square root of 3 times A. In the next step, I will copy the right triangle ABC in a new page and we'll analyze triangle ABC. Angle ABC equals to 90 degrees. What is the value of the hypotenuse AC? It's very easy to see from the drawing that AC equals to A plus A plus A plus A, that is 4A. What is the value of AB? The value of AB is equal to square root of 3 times A plus R. What is the length of side BC of the right triangle ABC? It is very easy to see from the drawing that BC is also equal to square root of 3 times A plus R. this is the right triangle, triangle ABC that I copied from the original drawing. In the right triangle, triangle ABC, both side AB and side BC, they are equal to square root of 3 plus r, therefore they are equal to each other. So those two sides are equal to each other. And we have the rule that in front of equal sides in a triangle, there are equal angles. So those two angles that are located in front the equal sides must be equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha. Why? Because of the fact that those two angles are located in front of equal sides, therefore they are equal to each other. And because of the fact that this is a right triangle, this angle equals to 90 degrees. Therefore, the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in the right triangle, triangle ABC, 280 degrees. Those two angles must be also equal to 90 degrees, because 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles in any triangle. So, therefore, alpha plus alpha equals to 90 degrees. Alpha plus alpha equals to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. Here we divide this equation by 2, and we get that alpha equals to 90 degrees over 2 is 45 degrees. So we found out that angle alpha equals to 45 degrees. So in the right triangle, triangle ABC, it is very easy to see that cosine 45 degrees is equal to BC. If you focus on this angle, cosine 45 degrees is equal to BC over AC. BC over AC. Okay? Cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R, and we have already found out that AC equals to 4A. And we also know that cosine 45 degrees is 1 over square root of 2, so we substitute cosine 45 degrees by 1 over square root of 2, that is equal to square root of 3 times A plus R over 4. Over 4A, of course. Here we multiply this equation by 4A, and we get that 4A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 4 by 2 times 2, and we'll get that according to this equation, four is 2 times 2 times A over square root of 2, that is equal to square root of 3 times A plus R. So here we substitute one of the 2's by square root of 2 times square root of 2. So here 2 times 2, and 2 is square root of 2 times square root of 2 times a over square root of 2. It is equal to square root of 3 times a plus r. So here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we have only with 2 times square root of 2 times a equals to square root of 3 times a plus r. Here we subtract square root of 2 times a from this equation, and we get that 2 times square root of 2 times a minus square root of 2 times a equals to r. So here we take a as a common factor out of those two expressions, and we'll get that so what is left from 2 times square root of 2 times a after we took from it a as a common factor, what is left is actually 2 times square root of 2, and what is left for minus square root of 3 times a after we took from it a as a common factor, what is left, it is actually minus square root of 3, that is equal to r. So in conclusion, we found out that the radius of the circle r is equal to a times 2 times square root of 2 minus square root of 3. Okay. In the next step, I will copy the right triangle DOT in the new page, and we'll analyze triangle DOT. Here, point O is the center of the circle. Point D is the point of the circle itself. This is exactly the definition of a radius. That is to say, OD is the radius of this circle that is equal to capital R. So I copy the right green triangle DOT. In this new page, so this is actually the right triangle DOT that I copied from the original drawing. In the right triangle DOT, it is very easy to see from the drawing that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. dt equals to a, so we substitute dt by a. do equals to r, so we substitute do by r. In conclusion, we found out that cosine theta in the right triangle DOT is equal to a over r. But here we have already found out that r equals to a times 2 times square root of 2 minus square root of 3, so we substitute r is substitute R by A times 2 times square root of 2 minus square root of 3. So here we have A in the numerator and A in the denominator, so A will get cancelled and we will left only with 1 over 2 times square root of 2 minus square root of 3. So in conclusion, we found out that cosine theta is equal to 1 over 2 times square root of 2 minus square root of 3. Okay? But our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result, this expression, and in this way we will get the value of theta itself. So we will operate the opposite function of cosine, that is cosine minus 1, on the result, that is actually equals to 1 over 2 times square root of 2 minus square root of 3 . And in this way we get the value of theta itself. Okay. Actually, if we operate the opposite function of cosine, that is cosine minus 1, on this expression, 1 over 2 times square root of 2 minus square root of 3, we get that theta equals to 24.203 degrees. Okay? So we found out that the size of angle theta equals to 24.203 degrees. Here, the size of this angle theta, equals to 24.203 degrees. We finished with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. So, in the drawing, we have square ABCD. You know that line segment AP equals to 5 units. Line segment PB equals to 3 units. Line segment PC equals to 6 units. And our mission is to find out the area of this square ABCD. So first of all, we did a construction. We extended side DC by a straight line, and from point P we go perpendicular on the extended side DC. Again, from point P we go perpendicular on the extended side DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in the extended DC as N. Then we did a second construction. From point B we go perpendicular on PN. Again, from point B we go perpendicular on PN. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Okay. Then we defined MB as A, and we defined PM, line segment PM as B. Okay, so we have here the great right triangle PMB. We implemented the Pythagoras theorem on this right great triangle PMB. According to the Pythagoras theorem, PB square equals to PM square plus BM square. Repeat again. In the right triangle PBM, PB square equals to PM square plus BM square. PB equals to 3 units according to what is given us the question, therefore PB square is 3 squared, that is 9, and it is equal to PM square, that is B square, plus PB, it is equal to PM square, that is B square, plus BM square, that is A square. So in conclusion, I found out that according to equation number 1, 9 equals to B square plus A square. And we know that all the angles inside square ABCD are right angles, so those 4 angles, they are all right angles. And here we extended side DC of square ABCD by a straight line, and this way we got line segment CN. DC is the side of a square, it is absolutely a straight line. And when you extend a straight line by a straight line, the result that is CN must be also a straight line. So DN is a straight line, and if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have here? This angle equals to 90 degrees, therefore the missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be equal to 90 degrees. So actually found out that inside quadrangle BMCN we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So if we focus on the lower side of segment line AM, we have this angle that is equal to 90 degrees, and this angle that is also equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees, so angle ABM equals to 180 degrees. Angle ABM equals to 180 degrees, therefore angle ABM is a straight line, because any angle that is equal to 180 degrees, it is a straight line. So if angle ABM is a straight line, it means that line segment ABM is also a straight line. And if line segment ABM is a straight line, it means that AM itself is also a straight line. So if AM is a straight line, then APM is a right triangle. So we will implement the Pythagoras theorem on the right triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus MA square. AP square equals to BM square plus AM square. AP equals to 5, therefore P square is 5 square, that is 25. And it is equal to PM square, that is B square, plus AM square. What is the value of AM? AM equals to X plus A, therefore AM square equals to X plus A square. So in conclusion, I found out that 25 equals to B square plus X plus A square. We open the brackets on this side of equation number 2 and found out that 25 equals to B square and X plus A square equals to X square plus A square plus 2AX. So here we have B square plus A square in equation number 2, and according to equation number 1, B square plus A square equals to 9, therefore we substituted B square plus A square in equation number 2 by 9, and we found out that 25 equals to 9 plus X square plus 2A square. We subtracted 9 from this equation number 2, and found out that 25 minus 9 is 16. So 16 equals to x squared plus 2ax. Here we subtracted x squared from this equation number 2, and found out that 16 minus x squared equals to 2ax. Then we divided this equation number 2 by 2x, and found out here that 16 minus x squared over 2x equals to a. So we got the value of a in terms of x. We already found out that BMCN has 4 integers, therefore BMCN that has 4 integers, quadrantal BMCN that has 4 integers is a rectangle. We know that the opposite sides of a rectangle are equal to each other, but that is to say BM equals to CN. But according to our definition, BM equals to A. So from this equation, A equals to BM equals to CN, we derive that CN is also equals to A. Here, CN is also equals to A. Likewise, according to the sum that the opposite sides of a rectangle are equal to each other, we get that BC equals to MN. But BC equals to X. So from this equation, X equals to BC equals to MN, we derive that MN is also equals to X. MN is also equals to X. Then we implemented the Pythagoras theorem on the right triangle, triangle PCN. In the right triangle PCN, PC squared equals to Pn squared plus Cn squared. PC squared equals to Pn squared plus Cn squared. PC is 6, therefore PC squared is 6 squared, that is 36. And it is equal to Pn squared. What is the value of Pn? Pn equals to b plus x, therefore Pn squared is b plus x squared. So here we found out that 36 equals to b plus x squared plus Cn squared. Cn equals to a, therefore Cn squared is a squared. So in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to b plus x squared is b squared plus x squared plus 2px plus a squared. So in equation number 3 we have b squared plus a squared. Therefore we can substitute b squared plus a squared by 9 according to equation number 1. We did it and we got that 36 equals to 9 plus x squared plus 2bx. We subtracted 9 from this equation number 3, and found out that 36 minus 9 is 27. So 27 equals to x squared plus 2bx. We subtracted x squared from this equation number 3, and found out that 27 minus x squared equals to 2bx. We divided this equation number 3 by 2x, and found out that according to equation number 3, 27 minus x squared over 2x equals to b. Okay, so we have the value of b in terms of x, and we also have the value of a in terms of x. Then according to equation number 1, we know that a squared plus b squared equals to 9. So we substitute a by the value that we found for a, and we squared it. In this way we got a squared. We substitute b, the value that we found for b, we square it, and in this way we got the value of b squared. So here a squared plus b squared equals to 9. We open the brackets on this side of equation number 1, and we found out that 16 minus x squared squared equals to 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And here we have the same denominator on both expressions, therefore we can add the numerator of this expression to the numerator of this expression. We did it, and we added 27 minus x squared squared equals to 27 squared, that is 729, plus x squared squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared, all divided by 4x squared. Here 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. and minus 32x squared minus 54x squared is minus 86x squared. All divided by 4x squared equals to 9. We multiply this equation number 1 by 4x squared. 4x squared times 9 is 36x squared. So, in conclusion, we found out that 2 times x to the power of 4 minus 86x squared plus 985 equals to 36x squared. We subtracted 36x squared from this equation. We found out that 2 times x squared minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Then we define z as x squared. If z equals to x squared, it means that z squared will be equal to x to the power of 4. Therefore, this expression in total will be equal to 2z squared minus 122 x squared. We substitute x squared by z, and we got minus 122z plus 985 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So those are the coefficients of our specific quadratic equation. The variable that we are looking for is z. So we put the data inside the equation, and we found out that z equals to minus b. B is minus 122, therefore minus b is minus 122. That is 122 plus 122 plus minus square root of b squared. Square root of b squared is square root of 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is 7,880, divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So here we found out that z equals to 122 plus minus 14,884 minus 7,880 is equals to 7,004 divided by 4. So z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4. So here we have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. But what is the value of z? According to our definition, z equals to x squared. So x squared, we found out that z is equal to x squared equals to 51.4224. So if we take out of this number, we'll get the value of x itself. Okay, so the value of x itself is the square root of 51.4224, that is equal to 7.17 units. So we found out that here x equals to AB, that is equal to x equals to 7.17 units, and it is impossible that x will be equal to 7.17 units, and I'll explain why. Because if we focus on the right triangle, triangle APM, in this right triangle, the hypotenuse AP equals to 5 units, and the hypotenuse is the biggest side in any right triangle. That is to say, AP is bigger than AM. AP is bigger than AM. So if AP is bigger than AM, let alone that AP will be bigger than AB, that is part of AM. So AP that is equal to 5 is bigger than AB that is equal to X. So here in the right triangle APM, the hypotenuse AP that is equal to 5 is bigger than AB that is equal to 5. So from this inequality we get that X is less than 5 units. So we found out that X is less than 5 units, while according to our solution, X is equal to 7.17 units, that is bigger than 5 units. So we got to a contradiction, therefore we cancel this possibility, and we left only with the second solution for Z, for the quadratic equation, that Z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 38.4013, and if we divide it by 4, we get that Z equals to 9.5775. And according to our definition, Z equals to X squared. And here, the area of square ABCD equals to X squared. So X squared is exactly the area of square ABCD, that is actually the area that we are looking for. And we found out that the area of square ABCD equals to X squared, that is equal to 9.5775 square units. And if we take a root out of X squared, we get the value of X. X equals to 3.09 units. And indeed X that must be less than the hypotenuse AP is less than 5, because 5 is bigger than X that is equal to 3.09 units. Okay, so the answer to the question is that the area of square ABCD equals to 9.5775 square units. We finished with the first question. Then I presented to you the second question. In the second question, we have the right triangle, triangle ABC. Inside the right triangle ABC we have a circle. Inside the circle we have triangle DOE. And our mission is to find out the size of this angle, angle theta. Okay, it is given as the question that AD equals to EC, and DE is twice as long as AD, and DE is also twice as long as EC. So we know that AD equals to EC equals to DE over 2. We defined line segment DE as 2A, DE equals to 2A according to our definition, and we used, according to what is given as the question, we know that AD equals to EC equals to DE over 2. But according to our definition, DE equals to 2A, so we can substitute DE by 2A. 2A over 2 is A. So in conclusion, we found out that AD equals to EC equals to A. That is to say, AD equals to A and EC is also equals to A. Then I presented to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisects the chord. We have the perpendicular OM that bisects chord CD. That is to say, CM equals to MD. CM equals to D, C over 2 and MD is also equal to CD over 2. We implemented all number 4 in our drawing. From point O, we do perpendicular to chord DE. According to rule number 4, DT equals to TE. DT equals to TE, but the perpendicular OT bisects chord DE. That is to say, divide it into two halves. That is to say, the first half DT equals to D over 2, and the second half TE is also equals to D over 2. So we got the equation that dt equals to t equals to d over 2. D equals to 2a, so we substitute d by 2a. 2a over 2 is a. So in conclusion, we found out that dt equals to t equals to a. That is to say, dt equals to a, and d is also equals to a. Okay? Then, here, we define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as N. We join points O and N together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R according to our definition. We have the radius OM that is drawn to the point of tendency, therefore this angle equals 90 degrees and this angle also equals to 90 degrees according to rule number 1. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore N is the radius of the circle that is equal to 1. ON is the radius of the circle that is equal to capital R. We have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees and this angle also equal to 90 degrees. In quadrangle MOBN, we have 1, 2, 3 right angles, therefore the fourth angle must be equal also to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So quadrangle MOBN that has 4 right angles is a rectangle. Here, quadrangle MOBN is a rectangle. We know that the opposite sides of a rectangle are equal to each other, that is to say MO equals to BN. But we already found out that MO equals to R. So for this equation R equals to MO equals to BN, we derive that BN is also equals to R. Likewise, according to the same rule, we get that MB equals to ON. But ON equals to R. So from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. MB equals to R. So we actually found out that quadrangle MOBN is not a rectangle, but a square. Why? Because all of its sides are equal to each other. They are equal to R. Okay, quadrangle MOBN is a square. Then I presented to you rule number 10. According to rule number 10, we have the common extreme point, we have the extreme point 3. From the extreme point 3, we have tangent PA, and we also have this straight line that intersects with the circle at point B and at point C. According to rule number 10, if this is the data that has been given to us, then PA square will be equal to PB times PC. Again, PA square will be equal to PB times PC. We implemented rule number 10 in our drawing. Here we focus on the extreme point C. From the extreme point C we have tangent CN and the straight line that intersects with the circle at point E and point D. Therefore, according to rule number 10, we get that CN square equals to CE times CD. Again, CN square equals to CE times CD. Okay. Implemented rule number 10 at point C. According to rule number 10, we get that Cn squared equals to Ce times Cd. So Cn squared equals to Ce equals to A, therefore we substitute Ce by A. And what is the value of Cd? Cd equals to A plus A plus A, that is 3A, so we substitute Ce by 3A. and found out that cn squared equals to a times 3a. A times 3a is 3a squared. So I found out that cn squared equals to 3a squared. We took out of this equation and found out that ca equals to square root of 3 times a. Here, cn equals to square root of 3 times a. Then we focus on the extra point A. From the extra point A, we have tangent AM, and we have the straight line that intersects with the circle, point D, and then point E. Therefore, according to rule number 10, we get that AM squared equals to AD times AE. Again, AM squared equals to AD times AE. I repeat again. According to rule number 10, if we implement it, rule number 10 at point A, we will get that AM squared equals to AD times AE. So AM squared equals to AD, AD equals to A, so we substitute AD by A times AE. AE equals to A plus A plus A, that is 3A. So we substitute AE by 3A, and we found out here that AM squared equals to A times 3A. So AM squared equals to A times 3A is 3A squared. We took out of this equation and found out that AM equals to square root of 3 times A. Here, AM equals to square root of 3 times A. Then I copied the right triangle ABC in a new page and analyze triangle ABC. This is triangle ABC that I copied from the original drawing. Here, the hypotenuse of AC equals to A plus A plus A plus A, that is 4A. The hypotenuse equals to 4A. Side AB equals to square root of 3 times A plus R. And side BC also equals to square root of 3 plus R. So those two sides are equal to each other. Side AB equals to side AC, and we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha because of the fact that they are equal to each other. This angle equals to 90 degrees, so the sum of those two angles must be also equal to 90 degrees. In order to complete the sum of the angles in this triangle to 180 degrees, those two angles must be equal to 90 degrees. So found out that alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divided this equation by 2 and found out that alpha equals to 45 degrees. So in the right triangle ABC, cosine 45 degrees equals to BC over AC. Cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R, and AC equals to 4A. Cosine 45 degrees equals to 1 over square root of 2. So we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A, and we found out that 4A over square root of 2 equals to square root of 3 times A plus R. Then we substituted 4 by 2 times 2 and found out that 2 times 2 times A equals to square root of 3 times A plus R. Then we substituted 2 by square root of 2 times square root of 2 and found out that 2 times square root of 2 times square root of 2 times A over square root of 2 equals to square root of 3 plus A plus R. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we left only with 2 times square root of 2 times A equals to square root of 3 plus A plus R. We subtracted square root of 3 times A from this equation and found out that 2 times square root of 2 times A minus square root of 3 times A equals to R. Then we took A as a common factor. What is left from 2 times square root of 2 times A after we took from it A as a common factor? What is left is 2 times square root of 2. What is left from minus square root of 3 times A after we took from it A as a common factor? What is left is actually minus square root of 3. So in conclusion, we found out that A times 2 times square root of 2 minus square root of 3 equals to R. So R equals to A times 2 times square root of 2 minus square root of 3. Then I copied the right triangle DOT, the right triangle DOT in a new page and analyze triangle DOT. Point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. So this is the right triangle DOT that I copied from the original drawing. In this triangle DOT, cosine theta equals to DT over dO. Cosine theta equals to dt over dO. dt equals to A and dO, dt equals to A and dO equals to R. So we substitute dt by R. R equals to A times 2 times square root of 2 minus square root of 3. And we got that, again, cosine theta equals to A over R. We substitute R by A times 2 times square root of 2 minus square root of 3. We have A in the numerator and A in the denominator, so A will get cancelled, and we have to leave cosine theta, that is equal to 1 over 2 times square root of 2 minus square root of 3. Then, in order to find the value of theta itself, we operated the opposite function of cosine, that is cosine minus 1, on the result, on this expression, and this way we got theta itself. So cosine, we operated cosine minus 1, that is the opposite function of cosine, on the result, that is 1 over 2 times square root of 2 minus square root of 3, and we got the value of theta itself. And the value of this expression is actually 24.203 degrees. That is to say, we found out that the size of angle theta is 24.203 degrees. Okay, so here we found out that the size of this angle theta that we are looking for equals to 24.203 degrees. Okay, thank you very much.